Hello friends, welcome to Physics Live channel. Today we are discussing about complex analysis 8th part class. So here we are studying about complex integration. Complex integration, and in which you have to put values z is equal to, that z is equal to r e raised to I theta. Okay, dz is equal to r I e raised to I theta d theta, like that. So this should be remember, and now we are going to solve the problems. So first of all, first problem, integral z square dz curve such that curve of mod z is equal to 1 from theta equal to 0 to theta equal to pi by 3. So we have to find that the z square dz from 0 to pi by 3. So z square in which z is equal to r e raised to I theta. Here r is equal to 1. Mod z is equal to r now. So r is equal to 1. So z is equal to e raised to I theta. Z square is equal to e raised to 2I theta. dz is equal to e raised to I theta into I d theta. So here in the integration, e raised to 2I theta, e raised to I theta into I d theta. So integral e raised to 3I theta into I is the d theta. So I into e raised to 3I theta divided by 3I from 0 to pi by 3. I cancel, that is 1 by 3 e raised to I pi minus e raised to 0. I pi is equal to cos pi, that is 1 only. 1. So e raised to I pi, that is cos pi. Cos pi is minus 1. So 1 by 3 minus 1 minus e raised to 0 is also 1. So minus 2 by 3 is the answer. Okay, very simple question. And next problem, integral 2z plus 3 divided by z dz curves are such that upper half of the curve in clockwise direction mod z is equal to 2. So we know that upper half of the curve means upper half means this, and in this clockwise direction means clockwise direction like this. So this is we know that 0, pi and 2 pi, like that. So we have to integrate from pi to 0, that is in clockwise direction pi to 0. So integral pi to 0 2z plus 3 divided by z dz. So we have to substitute z is equal to r e raised to theta, r e raised to I theta. So z is equal to r e raised to I theta, that is z is equal to r is 2 now. So 2 e raised to I theta, dz is equal to 2 e raised to I theta into I d theta. Okay, and we have to substitute z in this expression. So pi to 0, 2 into 2, that is 4. 4 e raised to I theta plus 3 divided by z, that is 2 e raised to I theta. D theta is, dz is 2 e raised to I theta into I d theta. So 2 e raised to I theta, 2 e raised to I theta cancel. So integral pi to 0 4 e raised to I theta plus 3 into I d theta. Okay, so we have to integrate this. So this is 4 e raised to I theta divided by I, and there is I also. So from pi to 0 plus 3 theta, there is also I, pi to 0. I cancel. So e raised to 0, that is equal to 1. So 1 minus e raised to pi is minus 1. So 1 plus 3 into 0, 0. 3 into pi is there. So minus 3 pi I is there. So 8 minus 3 pi I is the answer. 8 minus 3 pi is the answer. Okay. Next problem, that is integral C mod z dz. C such that left half of the circle in clockwise direction. Left half cycle. Left half of the circle. Left half of the circle in clockwise direction. Okay. So mod z is equal to 1 is given, and left half means this. From clockwise is there. So from this is pi by 2, this is minus pi by 2. Okay, so this is from minus pi by 2 to pi by 2. So minus pi by 2 to pi by 2, mod z is 1 now. So 1 z is equal to r e raised to I theta. So dz is equal to r e raised to I theta into I d theta. So r is 1, so I e raised to I theta d theta. So we have to substitute dz also there. Mod z is we substituted mod z and I e raised to I theta d theta. So that is I e raised to I theta by I. So this is minus pi by 2 to pi by 2. So e raised to I pi by 2, that is cos pi by 2 plus I sin pi by 2. I sin pi by 2 is 1. So I minus this is when substitute lower limit, that is cos pi by 2 minus I sin pi by 2. So that is minus 1. So this is I. So 2i is the answer. Okay. Next problem is about, this is closed integral z divided by z bar dz. This is the problem, and the curve is given here like this. The curve is like this, and we have to find the integral. So this is 1, this is 2. So how to do this? So we have to integrate this along these curves. So we can integrate from like this. This is the direction. So we have to integrate here and in this curve and this line, and there is a curve. So 4 sections are there. There is 2 lines and 2 curves. So we have to integrate along these curves. Okay. So first of all, we have to consider this. There is point also given, that is minus 2, minus 1, limits are given 1, 2. Okay. So along the x-axis, this is along x-axis. So first line, first section along a line is along x-axis. So y is equal to 0. We know that z is equal to x plus iy. Y is equal to 0 means z is equal to x, and we have to substitute there. So integral, this is from minus 2 to minus 1. So minus 2 to minus 1. So minus 2 to minus 1 x z divided by z bar, that is x divided by x bar dx. Okay, so x divided by x only, because we know that z equal to x plus iy, z bar is equal to x minus iy. So y is equal to 0 means z and z bar is same, that is x. So integral minus 2 to minus 1 x divided by x dx, that is 1 dx. So integration, that is equal to x from minus 2 to minus 1. So that is minus 1 minus minus 2, that is 1. So after integration of along the line we get 1. Second is a curve with a radius 1. So 2 is a curve. So z is equal to r e raised to I theta. R is given by 1, and also we know that it is in a clockwise direction from pi to 0. Okay, so we have to substitute pi to 0. Z is equal to r e raised to I theta. R is equal to 1. So e raised to I theta divided by z bar. Z bar is e raised to minus I theta into dz. Dz is e raised to I theta into I d theta. So this is e raised to I theta. This is e raised to 3I theta. So pi to 0 e raised to 3I theta I d theta. So we got that e raised to 3I theta divided by 3I from pi to 0. So 1 by 3 e raised to 3I pi is there, and e raised to 0. So e raised to 0 is 1 minus e raised to 3I pi. So okay, so e raised to 3I pi means cos 3I pi. Cos 3I pi, that is minus 1. So that is 2 by 3. So this is after integration along the curve. Okay, next we can see in this figure, that is a line. Line is from 1 to 2. So 1 to 2 line along x-axis. So z divided by z bar is always x divided by x dx, and that is 1 dx. So integral from 1 to 2, that is x dx, x from 1 to 2, and after integration we get 1. So after third session, from that we get 1. Okay, and next fourth session we know that in the figure there is a curve from this is an anti-clockwise direction from 0 to pi now, so f of radius 2. So integral 0 to pi z is equal to 2 is the radius, 2 e raised to I theta divided by z bar is 2 e raised to minus I theta into dz is equal to 2 e raised to I theta into I d theta. So this is 2 to cancel. So 2 e raised to 3I theta into I d theta from 0 to pi. So 2 into I into e raised to 3I theta divided by 3I after integration from 0 to pi. So we got from here I cancel 2 by 3, that is e raised to pi 3I pi, that is minus 1 minus 1, so minus 2 by 3. So after integration we got from first line, that is 1, plus second curve, that is we got from 2 by 3, and also there is 1 and minus 2 by 3. So after that we got 2 as after integration. Sorry, something we got wrong. So here we wrong, that is minus 2 into 2 by 3, that is minus 4 by 3 now. So minus 4 by 3. So we got minus 4 by 3 there. So this is we got here, that is minus 2 by 3. So 2 minus 2 by 3. 2 minus 2 by 3, that is 6 minus 2 by 3, that is equal to 4 by 3 is the answer. Okay, so it's a nice question and you have to solve this. And you have to remember that along a line, this is along x-axis. X-axis you have to put y is equal to 0 and put the limits. And if you check the curve from where to where, this is a clockwise curve from pi to 0. This is a line which is along x-axis, so y is equal to 0. And here this is a curve of radius 2 and this is from, it's a anti-clockwise direction from 0 to pi. Okay, this is the question. Okay. And next, when we think about analytic function, for analytic function, closed integral c f of z dz is equal to 0. That means f integral over c f of z dz is independent of the path. Independent of the path followed. So if it is closed, you know that for analytic function, closed integral f of z dz, that's equal to 2 pi I summation over residue. So for an analytic function, residue is equal to 0. That means the closed integral f of z dz is equal to 0 for an analytic function. But it is open, it is independent of the path. So these 2 points you have to remember. So this is a problem, that is an analytic function, and the question is a figure like this, and here just initial and this final, you know that this is 0, 0 and this is 1, 0. So we know that the function which is given by e raised to z dz. So this is an analytic function. So you know that this is independent of the path. If otherwise it is not an analytic function, you have to integrate here and here like this. Or here we know that it is independent of path, so we only do this integration like along x-axis. So that is z is equal to x plus iy. Z is equal to, along the line we know that it is only changing x now. So dz is equal to dx. So integral 0 to 1, only x changing from 0 to 1. 0 to 1 e raised to x dz is equal to dx. So e raised to x is e raised to x only. 0 to 1, that is e raised to 1 minus 1. So e minus 1 is the answer. Okay, so this is about analytic function. So next question, you have to consider the figure like this. This is the curve going. This is 0, 0, 1, 0, 2, 0. So we know that this analytic function, the curve is given by z dz, that is residues are 0 and it is analytic function. So this is independent of the path. So you have to integrate along the x-axis from 0 to 2 only. So 0 to 2 x dx, that is x square by 2. 0 to 2, that is 4 minus 0 by 2, that is 2 is the answer. Okay, very simple question. If it is analytic, you have to do the idea it is independent of the path. And this is a figure, the graph showing that it is moving from like this, and this is 1, 0, this is minus 1, 0. So you have to integrate the function z square e raised to z dz. So this is analytic. We know that it is along x-axis, so z is equal to x plus iy, in which you have to take z is equal to x. So it is a curve from 1 to minus 1. 1 minus 1, Z square is x square e raised to x dx. Okay, so we know that how to integrate this. How to integrate this? This is you have to know how to integrate this because x square 2x 2 0 e raised to x e raised to x e raised to x e raised to x plus minus plus. So this is from x square e raised to x minus 2x e raised to x plus 2 e raised to x from 1 to minus 1. This is after integration you got here. So that is after putting minus 1, that is e raised to minus 1 minus plus 2 e raised to minus 1 plus 2 e raised to minus 1 minus 1 e raised to 1 minus 2 e raised to 1 plus 2 e raised to 1. So you got like this, and this is 5 e raised to minus 1 minus this is e raised to 1. So that is we got like this 5 by e minus e. So this is from the figure like this. Okay. This is another question, that is curve is going like this. Going like this. So y is equal to x square minus 1. So we know that it is in an analytic function. So you have to integrate e raised to z dz. Okay. So e raised to z dz, that's equal to minus 1 1 e raised to x dx. So e raised to x minus 1 to 1 e minus, that is e minus 1 by e. Okay, or you can write that is e minus e raised to x minus e raised to minus x divided by 2. You got like this sin h1. Okay. So we got like this 2 sin h1. Okay. So you got the answer. It is analytic. So we have to integrate. This is the curve given. Okay. So we know that f of z is equal to u of x comma y plus iv of x comma y. And we know that if it is analytic, it should satisfy the Cauchy-Riemann condition. Dou u by dou x equal to dou v by dou y. Dou u by dou y is equal to minus dou v by dou x. You have to integrate once again, that is dou square u by dou x square is equal to dou square dou x dou y v dou square u by dou y square. If it is integrated with y, once again dou square y by dou x dou y. Okay, so if you add these, so dou square u by dou x square plus dou square u by dou y square is equal to 0, sum of these. So if you find that the function is analytic, del square u equal to 0, del square v equal to 0. So if a function is analytic, del square u equal to 0, del square v is equal to 0. This is known as Laplace equations. Laplace equations, and u and v are harmonic conjugate. U and v are harmonic conjugate. Okay, so this is all about that theory. And next we are going to another type of integration from minus infinity to plus infinity case. Okay. So here we are considering the integration from minus infinity to plus infinity f of x dx. Okay. So here in this question you have to replace x with the z. So we can use this complex integration. So we have to replace it with the minus infinity to plus infinity f of z dz. And we know how to find the singular points, and if it is denominator equated with 0 and we get the singular points, and after that you have to take the singular point selectively, because it is from minus infinity to plus infinity like this. Okay, so minus infinity to plus infinity like this. So it should be y should not negative, y always positive. So if you get a singular point that is y is negative, you can avoid that like this. Z is equal to 2i, 1 minus I and 3 plus 3i, in which you can take this and also this, but here y value is negative, so you can't take this singular point for a integration from minus infinity to plus infinity f of z dz. Okay, so this is one case. So you have to select the singular points according to the y as like this. And for one case, the singular point is lie on x-axis. If it is lie on x-axis, you get the integral like this. F of x dx is pi I into summation over residue minus limit z turns to infinity z f of z into pi I. Okay, so this is our expression if the singular point lie on x-axis. Integral minus infinity to plus infinity f of z dz is equal to pi I into summation over residue minus limit z tends to infinity z f of z into pi I. Okay, and if it is singular point does not lie on x-axis, so then the integration become x dx, that's equal to 2 pi I into summation over residue, 2 pi over summation over residue minus limit z tends to infinity z f of z into pi I. So this is Gauss-Jordan-Lemme constant, Lemme term. So here it is always commonly it is 0. So we generally studied about 2 pi into summation over residue before, but in minus infinity to plus infinity f of x dx, in which you have to consider this Jordan-Lemme when it is always 0, but sometimes it present. That is, if you are considering the term like this, x raised to m divided by x raised to n plus a raised to n. So there is n minus m is greater than or equal to 2. That is, if it is 2, it is 4, like that. So if this condition is satisfied, the terms are 0. If otherwise, you have to take the terms. Okay, it is just Gauss-Jordan-Lemme. This is limit z tends to infinity z f of z into pi I. The important thing you have to remember, that is, if the singular point is lie on x-axis, you have to take that is pi I into summation over residue, and it does not lie on x-axis, that is 2 pi I into summation over residue. And the next we are going to take the problems. Okay, So first problem, that is integral minus infinity to plus infinity f of x dx. So you know that minus infinity to plus infinity f of x dx, in which you are replace it with the f of z dz. Okay, so the question is minus infinity to plus infinity 1 divided by x square plus a square dx. Okay, so you have to replace it with the z, that is 1 by z square plus a square dz. And how to find this? You have to find the singular points. So z square is equal to minus a square, z is equal to plus or minus ia. So here we got two singular points, but we can take only one because y is negative here. So this is integration from minus infinity to plus infinity. So we can't take this value, only this. So singular point is plus ia. It is, you know, that plus ia, this is a y term, so this is not in lie on x-axis. So you have to find the residue. After residue function z is equal to ia, that is a in pole is symbol pole, so numerator divided by derivative of denominator at z is equal to ia, that is 1 divided by 2ia is the residue. And how to find the integration, that is minus infinity to plus infinity f of x dx is equal to, it does not lie on x-axis, so we have to multiply it with the 2 pi I into residue. Pi by a is the answer. Okay, so this is the questions, and we have a trick inside this. So this is our method to find the singular points and select the singular points and find the residue. And if it is lie on x-axis, multiply with the pi I, and it does not lie on x-axis, we have to multiply with the 2 pi I. Okay, this is the method, but there is a trick how to find the integration, that is dx like this form, that is n minus